So when you work from home, right? Actually, don't use your headphones. For a long time, if you start using it, will cause you some tingling problem in your ear and hissing sound. You will get hissing sound in your ear actually. So either use your laptop speaker or you buy some external speaker and try to use it. You use your headphone only for like some special meeting, important meetings where you want to discuss. Suppose for example, some people clarity won't be like we cannot hear properly actually. So in that case, you can use your headphone. Otherwise, you just use a laptop speaker or you buy one external speaker actually, a good one actually. So otherwise, it will have an effect on your ear actually. Okay, so we'll say jump into thing. Before getting into I'm not going to tell everything about pointers, but some basic thing which will help you to study pointers. Okay. So before that, I have to still cover certain things, and Senthil had requested you both, right, to study the dialogue. I asked whether to give training on that. He said like let them both try themselves like that. But then I told him like, okay, let me give the framework alone about the dialogue actually, because in your project you will come across this dialogue and you have to work on this dialogue actually. At certain points you have to modify certain things. So I will just I'll give the framework. So, a few more things about the same thing. Just let me take. Okay. The machine is very slow. You know about the constant, right? CONST. Yeah, you all know that the constant, right? You don't know. Okay, okay, I'll tell you. What is constant?
The value cannot be changed.
Change. Yes, that's fine. I will just tell it about that because I have to tell one more additional point related to that actually. So I will explain a little slightly. I will explain it. And there's something called qualifiers actually. So qualifiers means it gives additional quality to your variables like this constant is a qualifier actually. So static is one qualifier. So what static will do? Okay, no problem. I will explain that one also. So constant and static together, like most of the sample programs that you will see in internet, even in Microsoft, they will combine those things and use it. Just I'll give the importance of that one. And then the static variable is used for singleton pattern actually. So I'll not go into singleton, but I will explain that one. I was last week I was telling about the patterns, right? Okay. Sorry for the delay. Okay. Okay. First, I will create one project. Uh, so I will explain here. Suppose I'll declare here itself. So constant, maybe I will say wchar underscore t wch okay. I will just compile this one and see what happens. My machine went into some trouble actually, so let's say it's taking some time to recover. So it says error, right? So this is a constant must be initialized. So you can initialize this one with some maybe a value, maybe some like this. Now we'll try to compare. Oh, sorry. It's, okay, so as you said, we cannot change this variable. So that's what, if I try to change this variable to something else, maybe like this, right? So it says, like compiler itself says, expression will be modifiable actually. So you cannot change it actually, even if you build the same error will come actually. So it says you cannot assign a variable to it. One thing I can do, so that's it. This is about constant. Okay. Suppose constant parameters. Let's see what happens when you have a constant parameter. So that one will just remove this one. Okay. I will create a new project. Initially it will be very slow, but later on it will get picked up. I'll quickly change the configuration. Okay, as usual, I'll copy the code as it is. Okay, I'll remove all the other things. We'll just keep this constant variable. We'll keep this function also. So character w char underscore t. Okay, so ch. For now, I'll remove this return and make it void. Okay, so you know what happens, like it will, okay. So I will just call this function process. What is that process? Student. Okay, process student. Okay, I will just uh, pass this value. For now, I'll remove this global also, or I'll just okay, I'll remove it. So I'll move this vector here. Okay, we have something like this, and then I'll just ignore the boxes. For now, we'll just keep the stack memory box alone. So just like this, and then okay. So first, when it this line is encountered, first the stack variable is created here. Actually. So it's a wchar and initialize it with yes. So initially it with, and then it calls this process student. So immediately what happens, this parameter is there. So this, for this parameter it will create this one more memory wchar t. What happens is this value will be copied here, right? So last time we saw that one. So this this value is copied. So what it happens, like whenever you call a function, a copy of the parameter is created, right? So you understood, right? So you have the original thing. Whenever you pass the value, actually it will, a copy of it is created. And now what I will do is I will try to change here something like I will just increment it actually. So I will just increment it. And I will add the code here. Okay. So when it increments, it will work on this copy, not on this copy. So that's what I said, pass by value actually. So S will become T, it will become T actually. So I'll just overwrite it, okay, T. S will become T. Once it finishes up, the memory it got allotted gets deleted. So that's what it happens. So you know that. So it get deleted, and then it will come out of this, and this also get deleted actually. So what I'm going to do now is I'm going to declare this one as constant. Okay. So let's see what happens now. So immediately the compiler protects it, like this also is a constant. Now you means you cannot change the value of the parameter. So that's what it means. Fine, right? So whether you use it, you try to change it here, and whether you try to change in the function, it behavior is same. Now what I'll do, I'll remove this one. I'm removing this one. Now I will increment this one. So this variable is no more constant now. Now this value you can change it anytime, right? So we can pass also. We can pass this value. It will be passed into the function, but still you cannot change it. So what it means is, I will try to add this one. Maybe here. So this is what, and I will just remove this constant. So what happens is like this will become like when it start executing, this will become t first. It becomes t. I will just overwrite it. Okay, this will become t. Then process student function will be called. It will pass t here. So t gets passed here. Now let's see. Like imagine that red color line is not there. So here t will be passed, but still the compiler will not allow you to compile because we added here a constant actually, constant like this. So so you should not modify it actually. So you have to like you can only use it for WC out for processing or some printing, something like that. So you cannot change it. So so you all know this already. So out of this, one important point I will try to bring it first. Most of your website, the codes that you see, they will use this constant. Okay. So now next is static variable. So static variable. I will try to declare a static variable inside this function. That's what it will make you clear actually, instead of declaring in W main. Okay, let me create here first. So it's fine, right? It's okay. Now I will declare a variable, a normal variable, maybe int n number 1 equal to say okay, I will initialize it to 0. I will declare one static variable. Static can be declared for any type, float, char, like that. So n number, or if it is static, maybe we have to add yes here. That I am not sure, so I will add it yes. So it's I normally will do like this. So it's a static. Okay, we'll do like this. So follow the notation. So it's a static variable, and sorry, int type we have to declare int static int, and then we have to let's not initialize it. Okay, let's not initialize. Now we'll do one more thing. I will just remove this, or we'll just keep it. I will print this one. WC out in number. Okay. Okay, then I will again print static number 2. Okay. After printing, what I will do is I will try to increment both the things. Okay, let's see what happens now. So I will just increment it, and both the things I will increment. Okay. Okay, so uh, now we'll draw the stack memory for this one. I will just copy this whole thing. Instead of this process, I will just call uh, 3 times. Okay, maybe let's see what happens here. Can you guess what will happen? What it will happen? Can you guess what will happen to the static variable? Can you guess?
0.
Huh?
0.
Yeah, but okay. Okay, I will tell you actually. So, okay, let's take a new one. Okay. Okay, let's draw the static memory here. Now, first thing is this variable will be allocated. Then initialize with yes. Okay. Then it will increment this. It will change it to t. Okay. So next process student will be called. It will be passing this t to this process student. So a copy will be created. So I'll just create a copy of that parameter, and the value will be t. Value will be t. Now, okay, it will get printed in the console, and then now it will create two more. It will two more memory will be allocated int type. So I will just draw that one. So first thing is int. Okay, let's say like this much. Okay, 4 bytes. Okay, so it will be initialized with 0 first thing, and then it will be creating this one. Okay, I will just draw the box for that also. So it will be created for number 2. Okay, now let's see what it will get initialized. So I'll just compile it, and I'll put a breakpoint here. I think we can go for a break and come back. Okay, let's let it build it. Now a memory got allocated, and it will see like what it will get initialized, and then the two number will get printed. Okay, so whatever that number 1 is there, 0, and the number 2 actually. Next, it will increment this value actually, number 1. So that is this one. So this becomes 1 actually. So this becomes 1. let's this will also get initialized. First let's check what this number 2 initially. We didn't initialize with anything. Okay, so did it finish it? Okay, finished it. Okay, whatever it got initialized, it will just increment it. Okay, so once this process student comes out, let's what will happen is, now here is the point that you need to be carefully notice the point. This number 1 will get released. Okay, number 1 get, because the function is finished, and also the parameter also will get released. So these two things. Now I just F. Machine is slow. So not at allocated. So some value junk values got created. Like it got initialized to 0, like because I initialized with 0. Okay, so let's see, like you see that a static variable, it got initialized with 0 actually. So this value will be like this number 2 will become 0, will be 0 initially, and then what happens is it gets incremented and changed to 1 actually. So can you tell me what is the variable that get initialized to 0? No, the static variable. Any other variable? I told you. You don't remember? Unless we initialize only, it won't get initialized. It will be some junk value. But I told you one variable gets.
Default.
No. Yeah, default variable that anyway we are initializing. Global variable. So global variable also, like you remember in one session, like I had declared a global variable that gets created and then initializes itself with 0, right? So it's something like seems to be behavior like a 0, global variable, right? Let's see, let's get into it now. Now what will happen is like just increment this one. So after an increment, this is 1 and this is also 1. Okay, now let's come out of this one. So after it comes out of this function call, it goes into the second call actually. So the same process repeats it actually. So again the a new variable, new memory will be allocated, and this t will be copied. Then this number 1 int will be allocated in the stack memory, and 0 will be initialized. Let's see what happens to this number 2. Okay. So I'm going inside again now. Now, okay, let's initialize first. Okay, let's initialize. So number 1 is still 0, but what do you think number 2 will be?
1.
How?
Already
Yeah. Actually, the number 2 now just see it's earlier it got incremented with 1, and the same value it gets retained actually. So number 1 becomes 1 actually. So it means like once it comes out of this function, static variable is not deleted. So that's why I didn't strike it. So last value of this is 1 actually. That's why it remains the same value 1. Now let's print it and then we'll increment it. So number 1 will be 1 alone, number 2 will be 2 now. So we'll come out and then go inside again. I'll just print this I'll initialize it. Now number 1 will be just a 0 again. Number 2 will be 2 actually. So last value will be last value, whatever it is stored, that value will be there. So this will be always after this 3 process statement gets executed, it will be 2, means at this point this will be 2 actually. So after that it will increment and will become 3. Okay. So after that it will come out of W main, and everything like finally when everything gets cleared, this also will be get cleared actually. So this also will be removed. So all these things will be removed. First this will be removed, then this will be removed. So it is something like a behavior, like a global variable, right? So actually static variable, I'll tell you, I'll give the like one more diagram for the same thing. So I will explain it here in this box actually. So first thing, this variable memory will be allocated here. Initialize with yes, okay, and then will become T, and then it goes inside this process student. There's something called W varchar. This value will be a copy of wchar variable will be created here. I'll just create one more thing. I'll just create here, and then it will initialize with T. Initialize with T, and then it will print this, and then it will create one variable n number 1. Maybe it will be initialized with 0, but when it comes with static variable, a static variable is a global variable, but it's accessible only within that scope, with that function scope actually. So let me explain you. It will create one global variable here. When it come across this one, it will immediately create one global variable for static. So it will create here. It will automatically get initialized with 0 actually. So its behavior is like a global variable. So and the number gets printed, and then the number will increment actually. So n number 1, this will become 1. This will become again 1. Okay. So once this function is finished, only the variable declared inside the process student will get deleted. So global variable what is the property of global variable? It won't get deleted actually unless the process is finished. So that means the entire thing here. So entire thing that is within the function will get removed, and then this value will be retained, but it cannot be accessible to the entire file. It is a static, right? It is a static. So static, it is only related to that particular block actually, but behavior is something similar to global variable. So static variable is a global variable, but accessible only within the block. Okay, so you keep that in mind actually. So now it's fine, right? Okay. Finished. Okay. Now I have a question. Now suppose I am declaring a vector of u int. This is one type actually. This is nothing but sorry. uint 8 underscore t. Okay. You can just say maybe file data. Okay. Now you are reading a file. You are reading a file. Just imagine like we use any API file or create file or IO stream, anything. You are reading a 1 GB file actually. I'm storing in this vector actually. So 1 GB file, right? So I'll and you need to pass this data to a function for processing, maybe for image processing or something. Maybe void process image. Okay, so if you are passing to this function, what parameter I have to declare here? So you know that to pass a wcart, we need to pass create the parameter type will be wcart. If it is int, we need to pass int type, right? So now I want to pass this vector, this whole thing actually. So I want to pass this whole thing. So what type I have to declare here? Yeah, so what I have to, I want to pass this variable inside this function. So what I have to declare? You know, do you know? Okay, actually, see, I am passing this WCH variable, right, which is a type wcart. In order to pass inside this function, I have to create a similar type actually. You see the wcart, so not here. So here you have to pass the same thing, right? So for this one, what we have to pass? Vector of uint 8 underscore t. So we create here. This is the parameter that we need to pass. Maybe I will give the same name, file data param. This okay. So and then I'm calling this what is this vector of uint 8. This particular. So I will call this one. So I'll pass this one. So whatever the type is there, same type should be in the parameter also. Okay. So I'll just compile it. Okay, it got. Now let me draw one diagram for this one. I'll just copy the whole thing. I'll open one more thing. I'll remove all these things. This is the stack memory, and then this. Let's say we will create one. It will allocate one memory. Maybe like we are not sure like how much size. Maybe few bytes actually. So we will here this much I will create it. So, and then it will read. Suppose you are reading some file here. Maybe I will add here. After you declare it, you are just reading the file. Read file. Okay, you are reading 1 GB. So after you read the file, what happens is this vector size will increase, right? So maybe I will increase the size, not in stack memory but somewhere else. So you imagine like this is 1 GB file actually. So now we are calling process image and passing this 1 GB file data. So what happens is, first of all, this parameter vector uint8, like some memory will be allocated. Okay, we'll assume like a copy will be created, and this 1 GB data will be created here. Okay, imagine this also the same 1 GB. So 1 GB data, I will write it here. And here also 1 GB data. This is vector. Okay, so there is some mistake, means there is some logical, some problem is there here in this one, right? Do you sense what is the problem? Can you sense what is the problem in this type of program will work actually? Program will compile and work, but some logical errors or some mistake is there. What is the error? What is the mistake we are doing here? Look at this diagram actually, not at the program. Okay, so
Vector of
no, everything is correct. Syntax, everything is correct. What happens is you are reading 1 GB of data. We are passing to this function in this process image. There also it will create a copy, right? We just created a copy. So there also this will be created like this vector, and here also 1 GB of data will be copied here, right? So we are actually reading 1 GB, but actually in memory how much GB it will be? 2 GB. Suppose you are reading more files, like more data, like that means every time two copies will be minted. It's a waste of memory actually. So what you can do is, I will just erase this one. You need not work on the copy actually. So if you work on the copy, it's a waste of memory actually. So you need to work on this data actually. Okay, so what we have to do for that? What changes we have to do in this function, so that we need not create a copy. Instead we need to create work directly on this one.
static. Static.
No. Pawan, you don't know. So how to, like when you pass, when you call a function, you should work on this particular data, not on the copy of that data. So what changes you have to make in this function? You have studied about pass by value and pass by reference, right? So actually now this program is like pass by value. So value copy will be created. So it will work on that copy actually. Two copies will be created and work on the copies. But we should not pass as a value. We have to pass by
Address.
no. I will come back to that. We have to pass by reference actually. You understood, right? Reference will not work on the copy. It will not create a copy. It will directly work on this one. So okay, so I will just make a, how to declare it by reference? Ampersand, yes. So that's it. So what happens is you pass 1 GB data into this function. This copy, like since it's a reference, this will be directly working on this memory itself. Ajay, you will find it. So okay, maybe I will draw the arrow. Only if we mention it as a reference, okay? So keep this in mind actually. So only if you have a reference, only then. So we can avoid a lot of, we can save memory actually. If more number of memory, if we talk with, program will become slow actually. Recently in your projects, CAD application, customer were complaining about performance things, performance. So you must be careful in all these things. So whenever you use it, and okay, I will finish it. So okay, now 1 GB of reference I am passing. Okay, whatever the program here, I will change it here. So imagine this file process images. Maybe I will just try to access something like this, or code. So you are trying to access it, okay, like this. Maybe you are trying to print, or you are trying to analyze the first byte of that data. So, and you have a lot of other codes, you have a lot of function calls, maybe some 10 function calls. Okay, now my question is, you maybe some thousands of lines you are writing actually to process this data actually. Accidentally you write a code which will modify this file data. You should not modify it. So you should not do that actually. So, but accidentally it will happen. There are many chances that it will. You understood what I am trying to say. You are passing by reference. If you do like this, it is easy to change this data actually. You can change, but I just wanted to access for reading purpose. I don't want to copy actually for reading purpose alone. So, but normally what happens when you write a huge line of codes and functions, there are accidents that you will change the data actually, and it will create problems. So what I have to do, like this particular vector data, it should not be accessible. No, it should not be accessible. So don't confuse. One more static and one more thing I told you. Concept, yes. So just declare this as concept. That's it. If you try to accidentally change it, maybe 30. Let's see. Sorry. It won't allow you to compile it. So many of your code in your net or Microsoft samples, they and many people suggest you to write code like this. This will increase the performance. One more thing, you are working directly on this data. One thing, and you will not be allowed to change the data. That is second thing. This is a very safe way of programming. So most of the time when you come across any code samples, you will definitely will see actually, unless they try to change something. Suppose if you are writing one code that wants you to change the data, you just remove this constant. That's it. Okay, so you can change the data. So I told you about constant, static, and then this constant reference actually. What I am teaching you is very old C++ actually. Um, but that is the base actually. But nowadays, like we have a little more advanced thing that comes with like after C++11, C++ was like the standards were improved actually. After C++11, like now there's 19 and 17 or 19 is there actually. Lot of things they have added. Those things I didn't cover. For example, there is a double reference actually. There's something called double reference. So I will not explain, but double reference is there. And C and C++, they themselves don't have the threading actually. Advanced code C++11, above 11, you will have threading concepts, threads and pools. So, but the base is this. This is what the base actually. So, so maybe you will stop the recording. Okay.